Hi, I'm Paul. We're doing Leetcode must-know interview questions. Today's challenge is construct binary tree from in-order and post-order traversal. I think the previous challenge was construct a binary tree from in-order and pre-order traversal. So this should be pretty similar, except that the post-order traversal will be, I think it'll be the reverse of the pre-order traversal. Anyway, given two integer arrays in order and post order, construct and return the binary tree. All right. Well, so first of all, what is in order? In order is left, root, right. So looking at in order here. We start at the root of the binary tree, but the order again is left, root, right. So we go first to 9 on the left, and then the root, which is 3, and then the left subtree, but we don't start at the root. Again, it's left, root, right. So we get 15, 27. Okay. Post order. What is a post order traversal? Post order traversal is left, right, root. So here we'll start with the tree. We don't start with the root. We start with the left subtree, which is 9. Then we go to the right subtree. Although the right subtree, the root is 20, but we don't start with the root. We go left, right, root. So we get 15, and then 7, and then 20, and finally the root of the original tree, which is 3. Let's take a quick look at the constraints here. Length 1 to 3,000. Okay, well, 3,000 is not so important. The 1 is important because we don't have to deal with the possibility of empty arrays. Arrays are the same length, values, unique values. Okay, that's important. If they were not unique values, we would have to do it a different way than we're going to do it. Each value of post order appears in order. In order is guaranteed to be the in order traversal. Okay, yeah, it wouldn't be fair if that wasn't true. Post order is guaranteed to be the post order traversal. All right. Let's talk about how we might solve this. Okay, implementation. I have to admit that I tried the implementation once by copying the solution to the in order and pre-order traversal. Build the tree, get an in order and a pre-order, because it's really the same thing. It's just that the post order is, essentially reversed. When I did that, I got a Stack Overflow error. And I mean, it was getting stuck in the recursion, and I couldn't figure out why. So I'm going to have to try to implement it again. The algorithm is going to be the same. It's the same that we sketched out, but I'm just going to not copy the solution from yesterday because I missed something, and it just wasn't obvious to me what it was. So okay, so let's start here. Tree node. You know what? We still need. I'm still gonna do this and say private map integer. And we'll call it in order indices equals new hash map. Okay, I'll show you what we're going to use that for. I don't know. Do I still want to do this other thing? Oh gosh, yeah, I don't see why that wouldn't work. We'll do this private we'll call it, so post order is being passed in. We'll call it post order traversal. Private int array post order traversal. That is just going to be, we don't have to have that. It's just a copy of the post order traversal that gets passed into build tree. We're going to have a recursive method, and we can pass the post order array into the recursive method every time. That's one way to do it. Another way to do it is to just copy the post order traversal, because it doesn't change. Copy the post order traversal into a class variable and then just use it from there. Now, the in-order indices, we don't really have to have that either, but let's do this. Let's do something, write some code instead of just talking. Int n equals, we can call it post order dot length. The reason for having the map for int I equals 0, I is less than n, I plus plus is that the post order traversal, we can get the root from the end of the we can get the root from the end. We start with the post order traversal, so we get the root from the end of the tree. Now, next thing we want to do is we want to find the index of that value, which is 3. We want to find the index of that value in the in-order traversal. Now, we could just look through the in-order traversal. I think the limit on the length of that was 3,000, but you still don't really want to do that. An easier way to do it is to set up a hash map. The keys to the hash map will be the node values, and the value in the hash map will be the index in the in-order array. So we can do O1 lookups, because we're going to need to do that multiple times, is find a value in the post order traversal and then find the index of that value in the in-order traversal. So we can convert it to an O1 lookup by saying in-order indices dot put, and that will be in-order index I and I. So the value and the index. Okay. Anything else? I don't think so. So from this point we can say return build tree recursive 0, 0, 5. Well, you'll see what those are in a second, or you may remember from the last solution. But we need a method with that name. All right, private build tree recursive. All right, so what's going in here is, let's see, the in order index, that's where are we starting from in the in order array, where are we at in the in order array. We need a post order index, that is where are we in the post order array, and we also need the size. Oops, forgot something. Int let me scoot this over a little bit so I got more room. In order size. Okay. If size is less than or equal to 0, return null. So that'll be the case. I mean, we always try to build trees recursively, even if there is no tree. So first thing we do is we're going to build tree recursive. We're going to build the main tree. We are then in the process of building the main tree, we're going to build the left subtree recursively. Okay, and then we're going to build the left subtree and right subtree of the left subtree, that is the 9 node here, recursively. What we're going to find is that the size of those subtrees is 0, so we're going to return null. That's the base case on the recursive solution, and that's where it will terminate. So, all right. Root value, int root value equals. This will be in the Postorder traversal. Postorder traversal. And we need the index. It's going to be the Postorder index, which initially comes in as 0, plus the size minus 1, so we don't overflow it. Is that going to give us what we want? Because what we want is the last element in the Postorder traversal on the first call. So Postorder is 0 plus 5 minus 1 is 4, and that gives us this element right here. Can I highlight that one element? Yeah, the last element. That is the root value of the whole tree. It's 3. All right, next thing we want to know is what is the index of the root value, which is 3. What is the index of the root value in the Inorder traversal? And as it happens, it is right here. It is 1. Okay, and we can look that up in the hash map. So say int in order root index equals in order indices dot get root value. Okay. Let's create a root node with the root value. Tree node. Root node equals new tree node root value. Okay. Now, we are going to recursively build subtrees. So what would be the length of the left subtree? Well, once we find this index, the in-order root index, this 3 here, as we said when we were walking through it, that splits the in-order traversal into left subtree, right subtree. So the only thing in the left subtree is 9. So the left subtree length, left subtree length equals the in-order root index, which is 1, minus, what did we call that thing coming in? The in-order index, which was 0, 1 minus 0. It is 1. So the left subtree length is 1. All right, so let's build the left subtree recursively, like this. Root node dot left equals. Copy it. I won't copy that much. Copy this much. Equals build tree recursive. What is the order of the parameters here? In order, post order, and size. All right, build tree recursive. It's really going to be the same, isn't it? In order, no, not, in order index, post order index, and left subtree. Let me scoot that over a little bit more, so I think it's going to run off the edge of the page here. Left subtree length. Where did I just type that? I don't know where I just typed that. Hopefully it's not in the code window. Length. Left subtree length. Okay. Root node left. How is that going to work? So we're going to pass in 0, 0, 1, right? 0, 0, 1. What is going to happen when we do that in building the left subtree? Well, the root value is going to be the post-order traversal, the post-order index, which is 0, plus size, which is 1 for this subtree, minus 1. So the root value will be post-order 0. What is at post-order index 0? It is 9. All right, that's good. So the root value of the left subtree is 9. The in-order root index, when we look it up, is 0. The left subtree length would be the in-order root index, which is 0 minus 0. So there aren't going to be any subtrees for that. There's just going to be the root. There's just going to be the 9. Okay, so that looks fine. That looks fine. Let me scoot that back over a little bit. Root node left. All right, and then root node right. Let me copy this and then modify it. Root node right. Okay, build tree recursive. In order root index. In order root index. What is that in this case? Okay, yeah. So the in order root index on the initial call, it's 1. Right here, it's the 3. It is the 3 in the in order array, and to build the right subtree, we want to increment that because that takes us into these nodes here. Those are the right subtree nodes. So what we want is in order root index plus 1. That doesn't look good. Plus 1. And I don't like the way this is wrapping, to be honest. Let's do it like this. Whoops. Okay. In order root index plus 1. And then what do we need for post order? For post order, we need post order index, which is 0. Post order index, which is 0, and we got to increment that by the length of the left subtree, which is 1. That's the left subtree right there, that 9. If we increment it by 1, now we're into the right subtree nodes. So, in order root index plus 1, post order index plus the left subtree length. And for the length, it's going to be, oh, wait a minute. Am I using length here the wrong way? No, I think I'm using size consistently. All right. it is going to be size. Originally that was 5 for the call to build the main subtree. The right subtree is going to be size 5 nodes minus the left subtree length minus 1. That's the root. All right, we've taken everything else out. That's 5 minus 1, 3. So the right subtree should be 3. Okay. I don't see anything else that we need to do here. Return root node. All right. Let's try running it. Something happened, but I don't know what. Compile error. Private build tree recursive return to, oh, sorry. Yeah, return type. Okay, good. That is going to return a tree node. Okay, yeah, go ahead and run it now. Compile error. Can't find the symbol. Left subtree length. Did I not define the? Oh yeah, sorry. Okay, int left subtree length. Left subtree length. Okay, good. Okay, run it again. Runtime error. This dot post order traversal is no. Oh shoot. It is. Okay, sorry. Well, if I'm going to create that, then I got to say this dot post order traversal equals post order. Right? Oh no, not there though. Not there. Let's go up here. This post order traversal. Okay, that's good. This dot post order traversal equals post order. Okay, let's try it again. Index 4 out of bounds for length 1. On what? Unbelievable. Hold on. Okay, this is the most mistake-ridden. That shouldn't be 5. That should be n. That'll make it a little bit more robust. It'll work for arrays that are not of length 5. Okay, run it one more time. Accepted. All right, scoot this over. Submit. Why does that always drop down in front of my buttons? All right, how do we do? 2 milliseconds. Some people did better. It's all right. Memory is good. Okay. Okay, yeah, so I apologize for the back and forth on this, on typos, missing types, things like that. Important thing is to have a feel for the algorithm and a good understanding of what pre-order, post-order, in-order traversals are for binary trees. In-order traversal is root, left, right. Pre-order is left, root, right, and post-order is left, right, root. Feel free to like, subscribe, comment. Don't comment on the typos because I already apologized. What else? And see you next time.